So far, in this course, you have learned about how LLMs work, what their inherent limitations are, and how to communicate clearly and effectively with an LLM through structured and iterative prompting. Our discussion so far has assumed that we are chatting with an LLM through a simple chat interface, and that LLM is the only component in the system. But modern AI tools rarely rely on an LLM alone. Recall that an LLM generates the most plausible continuation based on patterns it learned during training. On its own, it cannot consult a database, browse a document, or look something up before answering. In this unit, we will explore how modern AI tools are built around an LLM to improve its usefulness by providing verifiable sources of information, supporting better personalization, and scoping our interaction to a specific project or task. Let's begin with the concept of grounding. Grounding means connecting an LLM's response to a source of information that can be checked. Instead of relying only on patterns learned during training, a grounded system can consult sources such as web pages, uploaded documents, databases, maps, or calendars before generating its response. Grounding can make an AI's response more accurate. Just as importantly, it can show you where the information came from so that you can verify it yourself. For example, when you ask a grounded chatbot for up-to-date information, it may first perform a web search. It can then provide its answer together with a citation or a link to the source page. Not all chatbots support grounding. When you use an AI tool, check whether it has access to external sources, and if so, which ones. Does it search the web? Does it cite sources? If it does neither, you are working with an ungrounded LLM, and its answers are based entirely on training data that may be months or years old. Knowing this helps you decide how much verification the output needs. That is an important point to remember. Grounding does not change how the LLM works at its core. The LLM is still generating the most plausible continuation of its input. And a plausible continuation is not necessarily the truth. The cited source is there so you can check the answer. You should compare the LLM's claims with the source it cites and confirm that the source actually supports those claims. The responsibility still belongs to you. Grounding is not limited to information from the web. Many AI tools also allow you to create a workspace, sometimes called a project. A workspace lets you gather content related to a particular task, and then ask the LLM questions or give it instructions based on that collection. For example, you can create a workspace containing a set of research papers or a set of lecture notes. You can then ask questions across those papers or notes, compare two documents, or trace a claim back to the specific passage it came from. A workspace is less useful for general questions, where the LLM's training knowledge is sufficient. So, ask yourself, Is the answer likely to be in these specific documents? If yes, a workspace helps. If the question is general enough that any informed source would do, a web-grounded chatbot or a direct prompt may be simpler. At this point, you might be wondering, if I upload a large collection of documents, won't the context become extremely long? And didn't we learn in Unit 1 that the long context can cause an LLM to miss important information? Well, that is a valid concern. So, let's look at how modern AI tools address this issue. In these systems, an intermediate layer of software sits between you and the LLM. When you submit a prompt, this intermediate layer searches the document collection and retrieves the passages that appear most relevant to your question. Only those passages, rather than the entire collection, are then passed to the LLM as part of its context. This keeps the context focused on the information that matters. It reduces both the length of the context and the amount of irrelevant noise within it. This technique is called Retrieval Augmented Generation, or RAG for short. We can extend this idea even further. Instead of uploading documents manually, you can connect an AI workspace directly to a cloud drive, an email account, a calendar, or another personal source of information. This can allow you to ask questions about a particular email thread, review your schedule, or summarize files stored in your drive. However, connecting an LLM to your personal source of information introduces a risk that you should take seriously. When you connect a personal account, the AI tool may gain access to everything permitted by the connection, not only the particular file or message that you have in mind. Before connecting any personal account to an AI tool, ask yourself 3 questions. First, what is the most sensitive information in this account? And am I comfortable with the AI having access to it? Second, is the connection read-only, or can the AI also send, delete, or modify things on my behalf? Third, where is my data being stored and processed? Is it on the tool provider's servers? And what are their data retention policies? If you cannot answer these questions, check the tool's documentation or privacy policy before proceeding. Now, let's consider another limitation of LLMs. LLMs are not always reliable at arithmetic or at precise computational tasks, such as summing the values in a column of a table or counting the number of specific letters in a word. These tasks are often better handled by dedicated tools, such as a computer program. Some LLMs are therefore trained to recognize when a tool is needed and to make use of that tool. When a tool using LLM receives a prompt that requires computation, it may avoid answering the question directly. Instead, it generates an instruction. The instruction specifies which tool should be used and what input should be given to that tool. In some cases, the LLM may generate a short piece of code that can be executed to solve the problem precisely. That instruction is then passed to an intermediate layer. The intermediate layer runs the appropriate tool and returns the result to the LLM. The LLM then receives the original prompt, its own tool instruction, and the result produced by the tool. It uses all of this information as context to generate its final response to be displayed to the user. When an LLM uses tools, it may say so in the output. But please beware that the output is still generated by LLM's most plausible continuation mechanism. So, the LLM may hallucinate that it is using a tool, but actually, no tools is used. So, when an AI system claims that it is using a tool, look for a visible trace. The formula, computer instructions, citations, and so on. Simply reading a sentence such as, "I checked this with a calculator," is not enough by itself. The same basic architecture can be used for web search. Web search is treated as another tool that the LLM can call. The LLM decides that the search is needed, generates a search query, receives the search results, and uses those results when composing its response. The tool is different, but the underlying mechanism is the same. The final limitation we will address in this unit is memory. On its own, an LLM does not remember anything between separate conversations. When you begin a new session, it starts without access to the conversation you had previously. To work around this, many AI chatbots provide a memory feature. With memory enabled, the chatbot can retain useful information from your past interactions. Over time, it may build a profile containing details about your background, your preferences, and the way you work. That information can then be included as context in future conversations. This allows the chatbot to respond in a way that is more relevant to you. For example, my chatbot has learned that I am a professor, the courses that I have taught, and what my research interests are. When I ask it to explain a concept, it can use more technical language and suggest papers that may be relevant to my work. I do not need to introduce myself again every time. Here are some good habits related to using memory in an AI chatbot. First, check if the chatbot you use supports persistent memory. If so, find out what the chatbot remembers about you. Second, periodically review what the chatbot remembers about you. For example, at the start of a new semester or a new project, is the profile that the chatbot has built still accurate and appropriate for your current needs? Many chatbots let you view and manage this memory. You can edit or delete entries in the memory. If you notice that your chatbot starts making unexpected assumptions, it is worth checking what it remembers about you. We have reached the end of Unit 4. In this unit, we move beyond interacting directly with an LLM and explore how modern AI tools are built around an LLM to supplement and extend its capabilities. When you encounter a new AI tool, it is worth pausing to ask, is this tool grounded? And if so, on what sources? Does it support a workspace? And would my tasks benefit from one? Does it use tools for computation? And can I tell when it does? Does it have a memory feature? And what has it stored about me? These questions take a minute to answer, but they will help you use the tool more deliberately and catch its limitations before they affect your work. We will now close with 2 points worth repeating. First, grounding an LLM does not change how it works at its core. It is still producing the most plausible continuation of its input, and therefore the output may still be wrong. Always verify the response against the sources it cites. Second, connecting personal accounts or uploading documents gives the AI access to information beyond what you might intend. Be deliberate about what you share and keep in mind the privacy implications of doing so.